Hi, my name is Scott. I'm from the Economics Tutoring Center, and today we're going to be talking about confidence intervals. Please make sure to check my language use and notation with your instructor because it may vary. Okay, so we're going to construct a confidence interval. This is an example problem. And it says, suppose the average life expectancy for women in Chad is 52 years. And that's a real estimate from the World Bank. Suppose that the standard deviation in years lived is 24 for a sample of 1,200 Chadian women, and we want to construct a 90% confidence interval for the average life expectancy of Chadian women. So, if you recall, to calculate the upper and lower bounds for a confidence interval, you start with your point estimate, x bar, and for the upper bound you add, for the lower bound you subtract the margin of error. And that margin of error is your critical value times standard error. And the reason why, so note that I write S for standard deviation and T for our critical value. That's because in the problem it tells us, for standard deviation, it tells us a sample standard deviation. And when you have a sample standard deviation, you always use t-statistics and you denote standard deviation with the S. If it were the known population standard deviation, then we would use z-statistics and we would write z-statistics and we would use sigma for standard deviation. But that's not the case here, so we have this formula for our confidence interval. This entire part here is the margin of error. So a lot of times it's useful when you're doing confidence intervals to calculate the margin of error first, just because it's easy to add and subtract one number. And then we can write down some of the information the problem gives us. So it tells us that average life expectancy is 52 years, so that's our x bar. It tells us our sample standard deviation is 24, so that's S. It tells us our sample size is 1,200, so that's N. And then if you look back at the formula here, now we have all the numbers we need to calculate this except for the t-statistic. And to find that t-statistic, if you look at at a t-table, it won't do you much good because our degrees of freedom in this example, it's n-1, and that's 1,199. You won't find that on most t-tables. So you'd probably have to use a t-calculator. You can do that online or in a graphing calculator. If you do that, you'll get your critical value is 1.646. If you notice, if you were to look at the z-table for a 90% confidence interval, you would find that, so we're not going to use this number up here, but you would find that a critical z-value is 1.645, so it's very close. The reason is that when you have a very big sample size like we do in this problem, the t distribution is very close to the z distribution. But either way, that's our critical t value here, and now we can construct the confidence interval. So really quick, I'll rewrite the numbers we had. X bar is 52, S was 24, N was 1,200, and our critical t 1.646. So like I said, it may be helpful to calculate margin of error first. And if you recall from the formula, that was the critical value times standard error. And standard error is just standard deviation over square root of n. So if we fill this in. We have 1.646 times 24 over square root of 1200. And if you put that in your calculator, you'll get approximately 0.6928 as your margin of error. So now we're almost done, because if you remember, our formula for the confidence interval is the point estimate plus or minus the margin of error. So if we note that the point estimate is 52, then so if you calculate that with your calculator, you'll get that the margin of error is about 1.1404. So now we're actually almost done with the confidence interval, because if you recall, the formula was x bar plus or minus the margin of error, because the margin of error is that whole part there, and that's what we add and subtract in the formula. So if you remember that our x bar is 52, then we have our, so sometimes you'll see it written as like LCL for lower confidence level. We start with the point estimate and we subtract the margin of error for the lower one, 1.1404, and that will give us approximately 50.8596. And then for the UCL, or upper confidence level, we start with the point estimate and we add the margin of error, and that will give us approximately 53.1404. So you might ask what that means. We have our point estimate of 52. It's just a sample mean, and we started at that number. We added a certain amount. We subtracted a certain amount, and when I say certain amount, both of those are margin of error. And then for these upper and lower numbers, we got, these are our confidence interval limits. And what that tells you is, because this was a 90% confidence interval, if we take a sample of this size, n equals 1200, we construct like a bunch of confidence intervals, we would expect 90% of them to contain the true average life expectancy. So remember, we don't actually know what that is, but that's what the confidence interval tells us. And you'll notice this is actually a pretty narrow margin, from about 51 to 53, and a lot of that has to do with how big our sample size was. So if you take a big sample size, you can get a pretty good estimate of what the average life expectancy is. So that's the example we have today about constructing a confidence interval. I hope it helped, and if you have any further questions, please feel free to come into the tutoring center or ask your instructor.